I, Nathaniel, and to commemorate the ending of the first part of the A-Level Mathematics series, we will do a Pure 1 paper. After completing all 10 topics of Pure 1, it is high time we actually do a real exam paper. So the exam paper we'll be doing is 970911 MJ19. So first, read the question, then we identify the topic, then we find details to find out which tools we use, and then we finally solve the question. Let's start with question 1. The term independent of x, in case the constant is 540. Now, you see, this expansion is quite different from our normal expression. So let's just calculate the powers. X6. But then, when we go to the second term, the x cancels out one of the x's, so x4. Then we continue this fraction, x squared, x naught, x negative 2, x negative 4, and x negative 6. So, if we number them from 0, 1, 2, 3, 4, 5, 6, then we calculate 6 choose 3 equals to 20. So, 20 times 2 cubed times k cubed equals to 540. 160 k cubed equals to 540. Excuse me. So k cubed equals to 27/8. No, we are not comparing the x's because they are just coefficients. Excuse me again. K equals to 3/2. Then, for this value of k, find the coefficient of x squared. We've already seen that the x squared is more like the second term, so 6 choose 2 equals to 15. So 2x to the power of 4 times k over x squared times 15 equals to ax squared. So we can take away all the x's from the equation as we are just comparing the coefficients again. And k is just 3/2, and then we just substitute, and then we calculate the final result. A equals to 540. Ain't it good? The x squared term is the same as the constant term. Pretty legit, huh? Question 2. The line 4y, where c is a constant, is a tangent to this curve. So, this question is certainly put in coordinate geometry because we have a line and a curve. And besides, it's also a quadratic type question where we have a quadratic, almost, and a line. So, we calculate in terms of x. So, x equals to 4y minus c. Or, if we put it another way, y equals to x plus c over 4. So, x plus c over 4 squared equals to x plus 3. Substituting in this equation, as we can see here, just substituting x plus c over 4 over y. So x squared plus 2xc plus c squared over 16 equals to x plus 3. X squared plus 2xc plus c squared equals to 16x plus 48. And then x squared plus 2c minus 16 x plus c squared minus 48 equals to 0. I've already figured out this term by now, but I'm going to show you how I did it. We calculate b squared minus 4ac equals to 2c minus 16 squared. The equal should be here. Minus 4c squared minus 48. And then we calculate b squared minus 4ac equals to 0. So 0 equals to 4c squared minus 64c plus 256 minus 4c squared plus 192. So this means that 4c minus 28 equals to 0, and hence c equals to 7. Because if we divide both of them by the whole equation by 16, then you get 4c minus 28 equals to 0. For part 2, find the coordinates of P. So we already figured out that C is 7, right? So this means that if we calculate x plus 7 over 4, actually we substitute C in the y. So 4y equals to x plus 7. And then y squared equals to x plus 3. So this means y squared minus 4y plus 4 equals to 0 with a bit of careful algebraic manipulation. So y equals to 2. Then, if we calculate 4 times 2, when we substitute, equals to x plus 7. So x equals to 1. And so p equals to 1, 2. Simple. Alright, let's move on to question 3. This is a circular measure question because we have circle, we have sector. Great. So A equals to half r squared theta, and the perimeter is the 2 radii 2r plus r theta, because in you go calculate, this is r, and this is r theta. And if we calculate, we need to find r theta. So half r squared theta is stuck with half r squared theta is a. So first we remove the half by multiplying both sides by 2 and dividing both sides by r. Now much better. Again, p equals to 2r plus 2a over r. There, do you understand right now? Alright, let's move on. The diagram shows a trapezium in which the coordinates of A, B, and C are 4, 0, 0, 2, and H, 3, H. The lines BC and AD are parallel. Angle ABC is 90 degrees and CD is parallel to the x-axis. Find by calculation the value of H. So, it's a trapezium, right? So, the gradient of AB is MAB equals to negative half. And we know about perpendiculars that the gradient of BC equals to negative 1 over negative half equals to 2. So on equation in H. So 3h minus 2 over h equals to 2. 3h minus 2 equals 2h. H equals to 2. You can use Pythagoras or use vectors if you had studied vectors, but in Pure 1 in the new syllabus, you're not expected to know vectors. Hence, find the coordinates of D. Great, just great. So the y coordinate of D is 6. Now coordinate of D is 6. So 6 minus 0, we calculate the gradient over, we have the x coordinate, so we put x because we don't know. And then it is 2, and then we calculate this, 6 equals to 2x minus 8, x equals to 7. So 7, 6. There. So we just use basic coordinate geometry. Sometimes it's useful to annotate the diagram, but in this case, you don't need to because it already shows that BC and AD are parallel. And x equals to 7, so 7, 6, right? Because the y coordinate and it's parallel to the x-axis. Moving on. The function f is determined by this. Express negative 2x squared plus 12x plus 3 in this form. Aha! It's a completing the square question. So, minus 2x squared plus 12x minus 3 equals to minus 2x squared minus 6x plus 3 over 2. And then, if you calculate this, you get x minus 3 squared minus 9 plus 3 half equals to minus 2 x minus 3 squared minus 9 over 2. Actually, it's 15 over 2 and minus 2 x minus 3 squared plus 15. Because if you go check the answer and substitute back, then this means that A equals to negative 3 and B is 15. Sometimes, just to get your more marks, you just write A equals to negative 3 and B equals to 15. So, question 2, which is not shown here, is asked us to find the range of the function. And since the range of the function, since the maximum is at 15, so f of x is less than or equal to 15. Sometimes it just asks you to find the maximum, in which case you just put 15. So 5 part 3, find the values of x for which g of x plus y equals to 0. So 2, f of x is minus 2 x minus 3 squared plus 15 plus 5 plus 1 equals to 0. So we just substitute f of x. F of x is like g of x. Got that? So minus 4x minus 3 squared plus 30 plus 6 equals to 0. Minus 4x minus 3 squared plus 36 equals to 0. X minus 3 squared equals to 9. X minus 3 equals to 3. And or minus 3 and x equals to 0 or 6. Keep in mind that if you want to get more marks, you must put both values of the square root because these values are equally important. It's not like greater root, lesser root, as in the lesser root is less important, but rather it just has less than numerical value. Alright, prove this identity. First, we'll need to express tan in terms of sine and cos. So 1 over cos x minus sine x over cos x equals to, so squared, 1 minus sine x over cos x squared equals to 1 minus sine x squared over cos squared x equals to, and if we calculate 1 minus 2 sine x plus 2 plus sine squared x over 1 minus sine squared x. And then we'll write the brackets and then we factorize it again. Sometimes you don't need to factorize, but I like to just expand and factorize again. And then 1 minus sine x by the difference of squares identity equals to 1 minus sine x over 1 plus sine x. And if you want to be a mathematician, you have to write a little box every time you do a proof. Hence solve this equation. So we use the identity. 1 minus sine 2x over 1 plus sine 2x equals to 1/3. 3 minus 3 sine 2x equals to 1 plus sine 2x. So 4 sine 2x equals to 2, sine 2x equals to half. And look at the range, it's just 0 to pi. So 2x, and then we have to find the values from 0 to 2 pi, because that's just the rule of mathematics. And then x equals to pi over 12, 5 pi over 12. Sometimes you might just like to find the principal root, or if you wanna, just write both. Question 7 is removed on the new syllabus, so it's omitted. There, it just makes our lines easier, doesn't it? The third and fourth terms of a geometric progression are 48 and 32. Find the sum of identity. Aha! We see progression, we think progression. So we need to find the common ratio first. Given the terms, it's 2/3. So then we need to find A. A equals to, since this is supposed to be AR squared and this is AR cubed, so A is supposed to be, hang on a sec, something, much better. So A just happens to be 48 times 3 over 2 squared equals to 12 times 9 equals to 108. And so S infinity equals to 108 over 1 minus 2/3 equals to 324. Two schemes are proposed for increasing the amount of household waste that is recycled each week. Great. So scheme A is an arithmetic sequence. So A equals to 2.5, D equals to 1.6. Then 24 months, then you have N equals to 24. So S equals to N over 2, 2A plus D, N minus 1 equals to 12, 5 plus 23 times 0.16 equals to 104 tons. That's quite impressive, but wait until we see this. 6% on the amount recycled in the previous month. This can't be right. Much better. So A equals to 2.5, D equals to 0.16. Actually, it's supposed to be R. because it's a geometric progression. By 6% of the amount recycled in the previous month basically means it's a geometric progression. So S equals to 2.5 times 1.06 to the power of 24 minus 1 over 1.06 minus 1 using the geometric series formula, and then we get 127 tons. Now, obviously, the geometric sequence is better than the arithmetic sequence. Great. Now, so the trigonometry question. Hang on, this can't be right. Now we can see the question. State the range of f. So 2 minus 3 cos x. Cos x has the range of -1 to 1. So minus 1 fx to 5 basically means that if you add 2 to the range of 3 cos x, you get -1 and 5. Sketch the graph. So let me do some poor sketching here. Sorry, I don't have a ruler because I am drawing on the computer. So, and then we have -1, 1, 2, 3, 4, 5. Actually, we don't need more, but let's just add this in for completeness. And then you would have pi, and then 2 pi, and then 3 pi over 2, and then pi over 2. So pi over 2 we have 2, on pi we have 5, on 3 pi over 2 we have 2, and on 2 pi we have 1, and at 0 we also have 1. So all we have to do is just connect the dots. Obviously, your paper drawings will be much better than this computerized drawing. You can also use Desmos to do the graphs, but I'm so sorry, there must be some technical problems here drawing this graph. Now another functions question. State the largest value of p for which g has an inverse. So this means that g, so p equals to pi. Why? Why is it pi? Because it becomes 1 to 1 after that, and then it just dips down. That's why. That's why. So what is value of p? Find the expression for g -1x. So x equals to 2 minus 3 cos y. So y just happens to be x minus 2 over -3 cos inverse this. Now do you understand why? Or if you wanna look nice, you can just negate both the numerator and denominator, basically just multiplying by a -1 over -1, and boom, we got that. Cos inverse 2 minus x over 3. Now we have second derivatives in here. So a curve for which d squared 1 over dx squared is 2x minus 5 and a stationary point at 3, 6. So this means we need to find dy over dx equals to x squared minus 5x plus c. So if we integrate the second derivative, we get the derivative, and we integrate the derivative, we get the function. And if we derive the derivative, we get the second derivative. That makes logic. So since it's the stationary point, we write 0 here, and then 9 minus 5 times 3 plus c. And this c just happens to be 6. Technical problems again. So now we integrate again. So y equals to 1/3 x cubed minus 5x squared over 2 plus 6x plus d. Now we just substitute 3, 6 in here. 9 minus 45 over 2 plus 18 plus d. A calculator tells me that d equals to 3 over 2. Y equals to 1/3 x cubed minus 5 over 2x squared plus 6x plus 3 over 2. Find the x coordinate of the other stationary point. So x squared minus 5x plus 6 has 2 roots. So x squared minus 5x plus 6 equals to 0. And then we use factorization. Factorization is simple enough for this question. X equals to 2 or 3. We reject 3. because we've already solved it before. Now we use the second derivative to determine the nature of the stationary points. X equals to 3, d squared y over dx squared equals to 2 times 3 minus 5 equals to 1. Let's check the equation. Yep. X equals to 2, d squared y over dx squared equals to 2 times 2 minus 5 equals to negative 1. So, maximum and minimum. Alternatively, you could use the shape on the x cubed curve, but using the d squared y over dx squared is actually more elegant. Oh, good. Now we have question 11. Sorry, it's a bit lopsided. It's because extra space here is probably to do the integration. Great. Why integration? It's because we need to find areas. So we need to find the normal, because we can clearly see the word normal in the question. Here, let me underline the word normal. dy over dx equals to 3 times half. It's negative half because the half is at the denominator, and square roots always have half. 1 plus 4x 3 over 2 equals to negative 6 over 1 plus 4x 3 over 2. So the dy over dx at 2 equals to minus 6 over 27 equals to negative 4 is equal to negative 2 over 9. So the perpendicular gradient equals to 9 over 2. The equation on the normal is y minus 1 equals to 9 over 2 x minus 2. Then we calculate when y equals to 0, minus 1 equals to 9 over 2 x minus 2. And then when we substitute, we get x equals to 16 over 9. Find the area of the region. So, in fact, we'll just have to, I will always have these technical problems coming up when I'm trying to do this. 5, showing all necessary working, the area of the shaded region. Very interesting. If we look at the shaded region, it has this very weird shape, actually. This is one of the weirdest shapes we ever seen. But don't worry, we use integration from 0 to 2. 0 to 3 over the square root of 1 plus 4x dx. And then we calculate, and then we use integration to get 3 times 1 over 2 times 1 over 4 square root of 1 plus 4x to 0. And then we use the limits to get, well, first we had to find the coefficients. So 3, then we get 6 square root of 1 plus 4x. And then we divide this by 4, so this is basically 3 over 2, 2, 0. And then 3 over 2, 3 minus 1 if we do the limits, and then we get 3. So the area of the triangle equals to half times 1 times 2 over 9 equals to 1 over 9, or you could use integration, but area of the triangle is the more elegant method. So the shaded area equals to 3 minus 1 over 9 equals to 2, 8 over 9. And we are done with this paper. Sorry, I don't have a tagline for this, but this has been a completely exhilarating video to make for me, and especially to do the paper, because this is the first time I do the paper walkthrough. I accept feedback from any of you to help make my paper walkthrough videos better. Well, see you, copper, and don't forget to say zinc when I come back.